Here I'm giving extra examples, extra practice for Lewis dot structures. And I think I'll just do two. Maybe the first one, I'll do I2. I2 is a diatomic molecule. If you look at your periodic table, we can find out how many electrons iodine starts with. So I'm using the square table model. And we'll look and see how many dots it should get. So here I find iodine, and it is in column 7, Roman numeral 7. So I put 7 dots around the iodine square table. And I'll use all 4 sides of the table. Maximum that can fit on any given side is 2. So this side is complete, as is this, as is this. This side is not filled. So a second iodine will be able to fill this slot. I'll draw the second iodine, in this case, strategically. And I'm using X's instead of black dots. So I can tell these are belonging to this particular iodine, and these are belonging to the other iodine. And I did this strategically because it's these 2 electrons here in the middle that these match up. These electrons match up to make the covalent bond. So I'll just draw my product here. So I see these as puzzle pieces. They fit together perfectly. And here's my product. I'll get rid of the square, but I'll still be imagining the square. So I can still imagine a square here. And the second iodine will fill the hole in the table. And at the same time, it's also completing its own octet. So I have octets filled. This is the dot structure for I2. The line structure would be simply I, line I2, line structure. There's my first example complete. For my second example, I'm going to do a more complicated molecule. NH2, actually I'll do NH3, NH3O. So I'll start again by thinking, what are my puzzle pieces? N is in column 5. And I'll think about the square table. Imagine the square table. A rookie mistake is to do this. 1, 2, 3, 4, 5. And you want to use all 4 sides of the table. You do not want an empty spot here. So this is a poor choice to begin. But I have an eraser. I can fix it. And if I do this, this is a much better starting place. If I then look at hydrogens, let's imagine each one has an X. These 3 hydrogens could fill the 3 slots on the nitrogens table. There are 3 slots to fill. If I did that, however, I'd have no place to put the oxygen. So that's another common rookie mistake, is to say, I'll fill up all those slots with hydrogens, and then, even though there's no space, I'll just glom this on there somehow. So I don't want to put the hydrogens on first. I'll put them on last. An oxygen will have 6 electrons, column 6. And this time I'm using little triangles. And I'm hoping you can see the square table here. And if I fill these two slots with hydrogens, I get H2O. That's not what I want. I want one molecule with NH3O. So the key to doing this well is to bond the nitrogen and the oxygen with each other. Leave the hydrogens to the end. Okay, so here's my nitrogen, square table. Used all sides of the table. Here's my oxygen. I'll bring it in here. And it also has a square table. And then hydrogens will fill the remaining slots. You should see 1 empty space, 2 empty space, 3 empty space. That's perfect because I have the 3 hydrogens. So here's hydrogen filling this empty space. Here's another hydrogen filling this empty space. And here's the last hydrogen filling this empty space. That is my dot structure for NH3O. I have filled the octet for both the nitrogen and the oxygen. It is complete. I can translate this into a line structure, carefully noting the positions of the bonds. N is bonded to O, and O is bonded to H. N is also bonded to another H, and another H. There's the line structure for this molecule. So there's a second example. Hopefully that's helpful. Use all 4 sides of the square table in the beginning. Don't fill up all your slots with hydrogens. Leave them till the end, perhaps. And make sure you have octets, not more than 8 and not less than 8. That's the way you do it.